today we're going to talk about the determination of jet velocity and nozzle efficiency experiment. Okay, so nozzles are a vital components in the world of engineering. You can find nozzles in turbines, jet propulsions, rockets. So in this little setup, we can actually do a little bit of a study on nozzle efficiency and also determining the jet velocity. Okay, so here you can see the apparatus here. So we have a few components. So I'm just going to go through one component, every one component. So alright, so below here we have the air inlet control. So this is the main air inlet control. So we're going to use this to regulate the inlet pressure of P1. So I'm going to show you after this. So just going a little bit through here. So this is the chamber pressure. Okay, chamber pressure, just right down below the chamber pressure we have the chamber pressure control valve. So this valve can be used to control this the pressure inside this chamber. So this is going to be very useful for us, especially when we're going to need to regulate the pressure inside this chamber to determine our nozzle efficiency and jet velocity. Okay, so right down here we have the micrometer adjustment. So the adjustment here is one of the readings that we're going to take to determine the outcome of the experiment. So we have the gauge right below here. So after this we're going to show you why this part is very crucial to this experiment and why this part is the most sensitive part of the apparatus. Okay, related to the micrometer adjustment gauge, so this is actually the voltmeter. So we're going to adjust the micrometer adjustment gauge, and we're going to need to get a certain reading at this voltmeter. So it's very crucial, so we need to be very precise when doing this experiment. Okay, so up here we can see two type of pressure reading. So this is the inlet pressure P1 and this is the chamber pressure P2. As I mentioned before, the chamber pressure is the pressure inside this chamber here, right down below here near the nozzle. Okay, and the P1 is actually the inlet pressure of the whole system. Alright, so on the right side of the apparatus we actually have this airflow rate reading. So this one is, the reading is actually in gram per second. So if you notice inside your graph sheet, the reading is actually in kilograms per second. Okay, so you need to change it accordingly. Sizes which we can change inside the apparatus. So I'm just going to show you here. To change it's very simple, just unscrew it, release, and here is the nozzle. Okay, so we can just unscrew it as usual. So the nozzle have different sizes. Okay, so then it's unscrewed here, so you can go ahead and change to a different size nozzle. Okay, so this one has the smallest openings and here you have the biggest. So I'm just going to show you an example here. Okay, make sure it's tight, put it back in. Alright, so it is as simple as that. Okay, so after this I'm going to show you how we need to calibrate the micrometer reading adjustment and also based on the voltmeter reading before we can actually proceed with the experiment. Okay, so right now I'm just going to show you how to run the experiment. So it's very simple. So the first thing we need to do is actually we need to turn the air inlet. Okay, so we need to let the air inside this apparatus first. So just rotate it counterclockwise to make sure that the air can go inside the apparatus. So as you can see right now, the air is not going inside because we just run having a dry run on the experiment to actually show you how the experiment goes. Okay, so once we turn on the air inlet gauge, so we will actually see an increase in the inlet pressure. Okay, so for this particular experiment, we need to set the inlet pressure up to 600 kilopascal. Okay, so when it reaches around 600, okay, so that value stays constant throughout the whole experiment. So you need to make sure that the reading of P1 is at 600 kilonewton per meter square at all times. Okay, so the next thing we're going to do is we're going to calibrate the micrometer reading here. Okay, so we need to turn on the voltmeter here. So I'm just going to turn it on. Okay, so you need to adjust the micrometer accordingly until the voltmeter reaches approximately around 0.5 volts. So adjust it accordingly and try to get as near as 0.5 volts as possible. Okay, so the calibration is needed. Calibration is needed every time you change the nozzle and every time you increase the chamber pressure. Okay, so it needs to stay between at least 0.5 volts to 1 volt. Okay, so this is very important because you will need to take the reading of the micrometer to be written down on your data sheet as per written here, the cantilever deflection. So you need to actually write that down. Okay, so next we're going to see here is the airflow rate. Okay, this is the gauge for the airflow rate. Alright, so this is very simple, but you need to make sure that you change the unit to kilogram per second, because here you can actually see it's gram per second. So don't be confused, you need to change it. Okay, so when the inlet pressure goes to 600, okay, you will see that the micrometer here will have a deflection. Okay, so once we have the first deflection, okay, so we just need to make sure that the reading stays around 0.5 volts, and there are a few critical readings that you need to take. So the first one is the reading here, okay, the micrometer reading. So you need to take that, the cantilever deflection. So that's the first one. So the second one is the air mass flow rate, which can be seen here. So you will need to see the top part of the floating marker that there. So the marker here will actually float to a certain level. So you need to get that reading. So let's say the floater, the marker floats around 3, so you need to take that reading of around 3 grams per second. Okay, so that's the second reading, the important reading. And the third is the temperature. So here is the temperature. This is the temperature for T1, as you can see from your table. But in this experiment, we're going to assume that T1 and the chamber temperature T2 is actually the same. Okay, so we're going to assume that both of these are the same. Okay, so that will ease the experiment for us. So I'm just going to put it back here. Okay, so as mentioned before, P1 will stay constant of around 600 kilopascal. For the chamber pressure, okay, so this is the thing that we're going to control. Okay, so we're going to increase the chamber pressure up until 600. Okay, so it's going to be the same as P1 at an interval of 100 kilopascal. Okay, so how you can change the chamber pressure is by controlling the chamber pressure control valve, as you can see here. Okay, so when you slowly turn the valve clockwise, you will actually see that the chamber pressure increases. Okay, the chamber pressure will increase, and you will need to recalibrate the nozzle as per discussed earlier. So every time you change the reading, okay, so every time you change the reading of P2, you will actually need to adjust the micrometer value, okay, to make sure that it stays at 0.5 volts, and you will then need to take the new reading of the micrometer as the gauge seen here. Okay, so taking a look at the table here. Okay, so a few things that you need to get. Okay, so the inlet pressure is, as I've said before, will stay constant throughout the whole experiment, about 600 kilopascal. Inlet temperature and also the chamber temperature is going to be the same, T1 and T2. The chamber pressure is the one that we control, so it will start from 0. Okay, start from 0, 100, 200, 300, 400, 500, and lastly 600. So you're going to end the experiment around here, around number 7. Okay, so the cantilever deflection. So this is to get the cantilever deflection. This is the one that I've said that you need to calibrate the readings before you get the final value. Okay. So the AMS flow rate, as mentioned before, inside here is kilogram per second. So you need to change that the reading that you get from the apparatus to kilogram per second. Okay, so that is it. So we need to change the nozzle. Okay, so we have a few nozzles here. So it is recommended that we do the experiment for at least 3 nozzles. Okay, nozzle number 1, 2, and 3. Or you can do the whole 5 nozzles. It's up to you guys. That's not a problem. Okay, but every time you change the nozzle, to make sure that the micrometer reading is calibrated before we proceed with the experiment. Okay, so make sure that every time you take a reading, this is calibrated. Okay, before we take a reading. Okay, so that is it for me today. So unfortunately, we're not going to show you the whole running experiment. We'll try to do so in the near future. But for today, that is all that I can show you. I hope you guys understand how the whole apparatus setup works. It's very simple. It's a very simple procedure, but you need to be very accurate to get the most accurate data that you can get. Okay. So I hope you guys can fill in the data sheet here properly, okay, and calculate all the needed value. As you can see from your data sheet, almost every formulas, every theoretical explanation is given here, so you can actually use all this information to write your lab report accordingly. Okay, so that it is from us. So thank you so much, and we'll see you again in the next experiment.